Hello everyone, and welcome to the NCHRP 081119 Data Integration, Sharing and Management for Transportation Planning and Traffic Operations webinar. My name is Anaf Morshed, and I'll help facilitate today's webinar. This webinar is the first in a series of 5, which will present an overview of data integration, sharing, and management for transportation planning and traffic operations, which began in 2019 and ran through 2023. The objective of this project was to develop tools, methods, and guidance for improving data sharing, integration, and management practices to enable transportation agencies in collaboration with private sector and public sector stakeholders to make better planning and operation decisions. As a quick reminder, at National Operations Center of Excellence, we offer a variety of resources to support the transportation system management and operations community. You can go to NOCO's website to browse through links for TISMO resources and news. Previous webinar recordings and case studies can be accessed from there. Now I'll cover a few logistics for today's webinar. We are recording this webinar, and the recording will be available on NOCO's website. All the attendees are encouraged to stay engaged by using the Q&A feature for questions and chat feature for comments. These are both on the bottom of your screen. We have a question and answer session at the end of the presentations. So if you have any questions, we encourage you to enter them in the Q&A area as they come to your mind at any time. Also, please feel free to enter your name and agency in the chat to say hello to your peers. Now I will hand it over to Kelly, Senior Director of Transportation at AEM, who will be moderating today's webinar. Kelly, the floor is yours.
Great. Thank you, Anaf. Hello, everyone. Thank you so much for joining today for this webinar. Again, we are here to talk about NCHRP 08119, Data Integration, Sharing, and Management for Transportation Planning and Traffic Operations. Next slide. So just a quick review of today's agenda. We're going to talk about the objectives of the project, the research approach, the project outputs. I'm going to introduce you to the research team, and then we are going to provide you with overview of 12 research products that are coming out of this project, and then quickly at the very end, the next steps for the project and what you can expect following this webinar. Next slide. So Anaf went over this when he introduced the project, but just quickly again, this project was a multi-phase project. It's been going on for a little over 4 years, so it's been a pretty big project, and we are wrapping it up next month. So we are at the very end, and that's why we're sharing the overview of the products and what you can expect to be looking for as TRB finishes up the review and publication process, so that you all have a kind of a heads up of what is coming. Again, the objectives were to, conduct research into agencies' use of data and some of the best practices, challenges, lessons learned, emerging practices specific to data sharing, integration, and management. And then based on that research was to develop products, as we've been calling them throughout the project, which are a variety of products, as you can see, but tools, methods, guidance for helping to improve and overcome some of the challenges and improve agencies' ability to share, integrate, and manage data, and in collaboration with public and private sector partners to help make better planning and operations decisions. Next slide. So the research approach was 3 phases. The phase 1 was information gathering and identification of products. This was generally the first year of the project. We conducted a comprehensive review of literature, looked at a lot of different data standards, spoke with a wide range of public, private, and nonprofit stakeholders. And from that research, we identified some very high-level transportation planning and operations use cases. These were not really specific use cases. We tried to keep them high-level and broad. so that we could still capture, some of the needs and the challenges associated with data sharing and integration and management. And then assessing those, what we saw in the literature, what we heard from the stakeholders, those challenges and needs with respect to data, and then identifying, originally we identified over 30 potential products that we could develop in phase 3. And then those were narrowed down and selected by the project panel. And phase 2 was to document the findings from the phase 1 research, and the approach was to create a website that was where we could, have all the information. It was easily searchable, it was cross-linked, and rather than a report, it was hopefully a more user-friendly way of sharing the phase 1 results. And then phase 3 was to take the products that were selected by the panel in phase 1 and develop those that were hopefully to help advance the state of the practice within and between transportation agencies and organizations. And we ended up developing 11 standalone products, which are what we're going to talk about today. So next slide. So just quickly, so where you can kind of find some of this information, not all of it is available yet, but the phase 1 in blue across the top, there is a phase 1 summary. It is on TRB's website. It's on the blurb page for, if you just Google NCHRP 08119 and you find the summary page of the project, there's a link to the phase 1 summary. We also developed an interim report for the panel, which was just an internal document, unpublished, but most of the information that was in that interim report is on that website, which was the phase 2 documentation. And that is being hosted by NOCO, and that is data.transportationops.org. We'll talk about that website in a minute. And then the phase 3, all the standalone research products that we developed have been compiled into one final research report, and each of the products is its own appendix. And those have yet to be published, but hopefully will be published sometime next year, and just wanted to make everyone aware of what's coming. So next slide. So for today's webinar, as Anaf mentioned, it's the first in a series of 5. We will provide a quick overview of the website and the 11 products that were developed during the project. So like the type of product, what the objective and purpose is, who the audience is, and then just the major sections or primary components. Unfortunately, we don't have time to dive into every single product on this webinar, but just letting you know what's coming. And then we do have 4 subsequent webinars planned, and I have a slide at the end of the presentation that will talk about when each of those is and how to register if you haven't already. And in these subsequent webinars, we will have an opportunity to go a little bit deeper into about half of the products that are listed here on the right. I'm not going to read all of these because we're going to go through each one of them. Next slide. But I want to quickly introduce the research team before we start talking about the products. So it was a big project. It's been going on for 4 years. It really has been a team effort. And so I want to give everyone some recognition for all of their hard work. Again, my name is Kelly Claver. I'm the Senior Director of Transportation at AEM Corporation. I'm the Principal Investigator for the project, and I was the lead for the TIM data product. Vaishali Shah is a colleague of mine at AEM. She has been the lead on the crowdsourcing data products. She's a Senior Director of Transportation Systems. Her career spans nearly 30 years, leading efforts across TRB and the federal government to bring innovations to practice. She currently supports the Federal Highway Everyday Counts Innovation, crowdsourcing for operations innovation, and the next Gen TIM EDC7 innovation. Mike McGurran is with McGurran Consulting. Mike was the lead for the work zone and 2 separate shared mobility data products that you will hear about. Mike's an independent consultant on intelligent transportation systems. Prior to his current role, he founded and led the Surface Transportation Division at Noblus for over 25 years. And Noblus has provided technical and advisory support to US DOT's ITS program since its inception. Ryan Fetchko is with VHB. He led the connected vehicle data product. Ryan is a transportation technology engineer with a focus on emerging technologies to support planning, equitable transportation solutions. His experience includes deployment of local, state, and federal policy, planning, design, and implementation of autonomous transit systems, connected vehicle design and implementation, big data for transportation systems, and TISMO for multimodal applications. We have 3 folks from Jacobs. Brian Burkhardt led the ICM data product. Brian is the Jacobs Global Principal for Advanced Mobility Systems and has over 30 years experience in the advisement, planning, and design of complex transportation systems, and specializes in systems engineering, traffic and ITS management, and EV charging infrastructure. Dan led 2 freight data products. He is an experienced project manager and data scientist, and he is recognized as a global principal for data insights and predictive analytics at Jacobs, and serves as a subject matter expert in freight planning. And Ed led our network conflation product. And Ed is the Americas region travel modeling practice lead at Jacobs with over 45 years of experience developing, implementing, and applying traffic and travel models, including experience in integration and application of geographic databases. And finally, Pat Noyes with Pat Noyes and Associates was supporting multiple products, including the crowdsourcing and the TIM products. And she's the principal at Pat Noyes and Associates for over 30 years and is a national leader in transportation systems management and operations, and extensive experience in transportation planning, traffic engineering, stakeholder engagement, and decision support. So just a big recognition for this team and all the work that has gone into this project. So with that, next slide, we are going to start diving in here to these research products, which is really the primary output of all of the work that has been done. So next slide. So starting with the website that I mentioned. So again, this is transportationdataops.org. I think it was on a previous slide. But again, if you Google NCHRP 08119, you will find this NOCO website. And this is the outputs of the phase 1 research. So next slide. So it's a centralized, searchable, web-based research library documenting the knowledge, use cases, challenges, needs, lessons learned, guidance tools, etc., that were discovered during phase 1. There it is, data.transportationops.org. Next slide. So really there's 3 primary sections to this website. So in the upper left-hand diagram, you can see the data applications areas. These really followed those use case categories or use case areas that I mentioned, the high-level ones that we focused on in phase 1. So you can see connected vehicles, crowdsourcing, freight, ICM, planning, shared mobility, smart cities, traffic incident management, transit ITS, and work zones. So within that is really just the findings of that research and tools and guidance that was already available at that time. You can find, so there's a lot of information here. The research products tab provides a little blurb on each product, and then you can click view more, and there's like maybe a half a page to a page of information summarizing the research products. Again, those research products will be available as part of the final research report for the project on TRB's website. And then the last tab in the lower right, you can see the additional resources. So this includes information like agency data policies and sample agreements, relevant committees, data platforms and repositories, data specifications and frameworks, etc. Some of this stuff is cross-referenced to the data application areas, and others of it is standalone. I will mention that we finished the phase 1 research probably back in 2021, and the website pulled the website together in early 2022. And we have developed the research products, but haven't really added anything to the website since then. So you may know of something in a particular area that's available now that wasn't back then. So just wanted to point that out. But I think there's still a lot of really good information here, all in one place, and relatively easy to kind of search. And hopefully you'll find some information that is useful and helpful. Next slide. So I'm going to turn it over to Dan. Dan's going to talk about the two separate freight products that we developed. So Dan.
Thank you very much, Kelly. My name is Dan Cedar Jacobs, as Kelly mentioned. I'm just going to take you through the first product, and then I'll follow up with the second one. This first product came out with a purpose, right? It's a lightweight, what we call freight decision tree. And it came out because of an initial need that we saw in the industry, where a lot of people use freight data, but sometimes they are not sure which exact data sets they should select for a particular use case. So let's go to the next slide, and then I'll give you a quick overview. So the goal here was to have a very lightweight interactive web tool that you can just go in there, click, move things around, and get information that you need. And one of the objectives was that we know agencies are using big data. However, how do you know which data is best supports a particular use case? And when we talk about use cases, I will have that in the next slide. You realize that there are a number of use cases for freight data, from traffic operations to commodity flows to OD demand, to track weights, all kinds of things that people are using the data for. And so what the goal here is, can we have something that is very simple, that is very straightforward, that is very easy to use, but quite informative? Right, so on the next slide, using JavaScript and HTML, this tool was developed. You'll find a version of this tool on the website that Kelly shared with you. It's written such that we did the initial assessment. We found 4 use cases: OD analysis, track volumes, track congestion, and track parking. So using those examples, we're able to then expand and give more insights to what people are trying to do. So let's start off with, let's say, OD analysis. And so looking at the slide here, most OD analysis will require 2 forms, either with commodities or without commodities. So if you have to choose the option without commodities, then the tool is going to ask you, what question are you looking for? Are you looking for track flows by route, or are you looking for custom OD analysis? When you say I want something that is by route, then it selects the databases or the data sets that are currently available for you to use. And so A3 comes up, INRIX, Geotab, Streetlight, and then Transearch. If you were to select a different option, such as a custom origin destination analysis, then it will pop up and give you the other options or the other data sets that are available for you to use for this particular use case. So once again, you can try it out on track volumes, you can try it out on track congestion and track parking. And what the tool will do is that to just try to give you its best idea on what each of these data sets can do for you. So we started this off just having 10 public and private data sets, and where we are hoping that there'll be an opportunity to expand this to add additional data sets beyond this initial set of data. Next slide. All right. So as I described earlier, as the subtree expands and you click on the final node, you realize that there's going to be some additional information about that data. It's going to have information such as when was the data collected, what is the purpose of the data collection, what is the the temporal granularity, what is the spatial granularity, and then we also included some use cases. And we know DOTs and other clients are already using these data sets for their exact purposes. So we're able to link up with those use cases or those reports. So if you look on the right, at least this was a FAF website when this was being developed. We took some screenshots and then you're able to see how your particular use case is being addressed in the FAF tool. Just FYI, as Kelly said, this was done a couple years back. And so I know there's a new FAF update and a new FAF website. So this screenshot is a bit older, but however, it just gives you a concept or the idea behind this particular tool. Okay. I think we'll be taking questions in the chat, and so feel free to follow up on this. Okay. All right. The second tool, which feeds off the first tool, was that okay, now that I have an idea what data sets I have, what if I find myself in a position where I need to integrate multiple data sets in order to answer a particular use case? So if you go to the next slide, that is what informed this particular product. It's because we found out that as much as people would like to use a single data set, there's always a need, especially for very complex problems, to be able to integrate data and identify what are the pros and the cons and the gaps, especially the gaps that exist between some data sets, and how do you go about filling those gaps? The challenge, however, if you go to the next slide, is that most of these data sets already have predetermined, right? They have predetermined fields that you can query on. We haven't, however, come up with a proper or a robust way of querying these data sets to even determine if these data sets will actually answer that particular use case. So in this particular product, we started off by just looking at four key variables, right? Which is location, time, vehicle classification, and use case. And if you are to refer to the global ontology on the right, which this was developed a couple years back in another research project, you see that these variables are quite common in a good number of freight-related data sets. And we go to the next slide. So illustrating here, using the place variable, if you were to use a place or the location variable, you have different data sets giving you different responses, right? So in this particular example, I'm showing Geotab, I'm showing Streetlight, and then the NREX NPMRDS data sets. And if you look very closely at the variables on the right, you look at the fields that are being queried, you realize that there are some differences between those three data sets, even though they may be saying the same thing or they may be referring to the same place. So it therefore requires some form of transformation using a common or a baseline data set. And in this case, we are using the Census Bureau's published classification of places as the baseline. And once you have that in place, you can then map what the census says to those specific locations on either of those three data sets that you have here. Similarly, if you move on to the next, if you look on the next the next set of queries where it looks at relationship mapping, there may be opportunities that some data sets will still pass. So in this case, the Geotab, Streetlight, NREX once again pass that test when you dive deeper by census tract, by block group, by census block, or by zip code, or TAZ, or a custom zone. And then however, depending on how or what we've done with some of the data sets, only one data set, for example, NREX, allows you to do like a custom query in a particular location at the time that this was being done. We know since then Geotab has expanded their capabilities, and so has Streetlight, that you're able to do some much more custom spatial queries, which initially was not possible. So taking this concept of mapping between various data sets, if you move on to the next slide, we're able to then examine these sample data sets that we have here. So we use Geotab, NREX, Streetlight, H3, HPMS, the bridge inventory data, the crash database, and there's a lot more other data sets that you can add and go through this exercise of ticking the box on how these data sets talk to each other in terms of what are the similarities and what are the differences and what are the things that can be done if you are querying them together. In this case, we propose the parameters on your left. Those parameters on your left provide you with a common query to be able to map all these data sets and to find what you are looking at. There's a bit more complexity that I will not be able to get into in today's presentation. However, we have another presentation scheduled in December, which Kelly is going to announce, that will get into more details about how we address some of these specific use cases. So on the last and final slide, if you go to the next one, this is kind of the idea. The concept is that you have a common base, which is an origin and destination, and whatever parameters you'd like to query. And then this is just a snapshot of the algorithm showing that if you were to use these parameters, how does the system go about querying all these data sets and pulling out the ones that you need for your particular use case. And once again, like I've said earlier, I'm looking forward to presenting the entire details or getting to the nitty-gritty of this. But this is one of the contributions that this NCHRP project came up with. And it was a great exercise to see how well some of these data sets talk to each other and what are the issues and discrepancies that we continue to address in our field. Thank you, Kelly.
Thanks, Dan. Okay, moving on to the work zone product. Turn this over to Mike.
Hi, good afternoon, everybody. So this was basically a case studies looking at the state of the practice for 5 different jurisdictions and agencies and what they're doing with smart work zones. Next slide. So the idea was to look both at how they were using smart work zone technology in their roadwork and how they were using real-time data, connecting that in with both their internal systems and also using emerging standards like the work zone data exchange to provide information out to third parties that then would provide it to the public, whether those third parties were groups like Google or Waze or automakers. The target audience for this with state, regional, and local public sector agencies that are looking to adopt and make broader use of work zone technologies, tell them what other agencies are using, what's worked, what didn't work, what are some lessons learned along the way with that, as well as establishing work zone data exchange feeds to provide out to third parties. Next slide. So as I mentioned, there were 5 different case studies that we looked at. So I'll go over each one of those briefly. One of those was the Massachusetts DOT. Some of the aspects from Massachusetts, they are using smart arrow boards, and they have a new application in the last couple of years, the Smart Work Zone Manager, which pulls data from that real-time sensors, and that also is used internally, as well as producing a work zone data exchange compliant output that third parties can then access and use. One of the other unique aspect is the original work zone data exchange feed is basically a standard for public agencies to provide real-time work zone data out to others. As I mentioned, whether that be groups like Waze, Google, other jurisdictions, automakers, et cetera. It didn't cover what's the format for getting that data from smart work zone devices into the agency systems. Massachusetts developed an open specification, an open application programming interface for that, that they then required their vendors to use. And that has now become the basis for a second half of the work zone data exchange specification. Basically, with some modifications, they adopted what Massachusetts had developed to become a standard API now as part of the national standard for smart work zone devices to communicate back with public agencies. Second case study was the Regional Transportation Commission of Southern Nevada. One of the unique aspects they have used one of a couple of different contractors that are out there that uses machine learning and automated image recognition and uses dash cams. And these are dash cam feeds from just everybody, cars from people who have dash cams that sign up, as well as fleet vehicles. And basically they have a system then that will recognize work zone equipment, barrels, cones, arrow boards, what have you, and geolocate that data so it can provide real-time information on where there are active work zones in the area. And as a side benefit, they found it also helps them identify where a work zone's been completed and they forgot to do a full cleanup. They'll find, here's 3 barrels that's been sitting there for 2 months on the roadside after the construction's done. We should really go pick them up. And the automated machine vision just picks that up and reports that. Other area that they've worked on is they developed a very comprehensive specification for what all these different smart work zone devices, whether they were temporary traffic signals, smart arrow boards, what have you, what information they needed to provide, what format they needed to provide it in. And they tried to get the other agencies that are under the umbrella of the Transportation Commission to adopt this and specify it. Unfortunately, they did not get a lot of adaptation of that. It might have been, and I'll talk a little bit more in contrast in a minute on what Iowa had done, that it tried to bite off too much at once. But another area they're working on is there's a private company called HosAlert. They have a product that disseminates out information that originally started with where were emergency vehicles in real time and reported out the locations of emergency vehicles. HosAlert is expanding and picking up these real-time work zone data exchange data feeds from various jurisdictions and including that then in their own data feeds. And Southern Nevada is one of the agencies that's feeding information into them. The Kentucky Transportation Cabinet, they've been doing a lot with smart work zone devices, especially to monitor speeds within the work zone, to make sure that speed limits are being followed. When they're not being followed, they can identify that, try to figure out what actions to take to try to get more vehicles to follow the reduced speed limits, and also how those are tied into crashes. And they received a grant, and they're currently working on implementing a work zone data exchange feed using that federal grant money. Next slide. So the Iowa DOT, they took sort of a different approach than what Southern Nevada did. They started solely with smart arrow boards, no other devices. And initially, so that was only where there was a lane closure, hence you had an arrow board, and only on interstate highways. And they required their work zone contractors to provide those. That was very successful. They expanded that to be all state roads, and that's being expanded even further this year. So they started small, had success, expanded, had more success, and expanded both the scope into additional devices, as well as added scope as to what roadways were covered. And this data that comes back from the smart work zone devices is being integrated with other real-time data, as well as work zone planning data in their traffic management systems. And then finally, the fifth case study was Minnesota DOT. They have used smart arrow boards. They did a pilot project. They found that was successful, but they had some funding issues. Currently, they're not using smart arrow boards, although they hope to use them again. They are working on some innovative systems that the work zone workers will carry, such that they could automatically check in, and basically it's known that there's active workers actively working in a particular work zone area, and that this will be part of the work zone data exchange feeds that are then provided out eventually out to consumers. Also, they had a traveler information feed already. A number of states use a system called CARS to provide that. They're one of those states, and they're basically planning to continue that, but also take that CARS data along with the new smart work zone data and generate a work zone data exchange compliant feed that meets the standard. Next slide. So for each of these 5 case studies in the report, goes into a lot more detail, obviously, than I've covered here in 2 slides. It talks about the history of what they had done in the past, what they're currently doing in the area of smart work zones, and data feeds out to third parties, as well as what they have planned for the future, lessons learned from each one, what types of technology they use, how that data is being used, and what data is being collected. And it compares and contrasts in the report, as I mentioned a little bit with that one example of starting small and growing or trying to take off bigger chunks at once. It compares and contrasts the different agencies' approaches and draws lessons learned on what seems to be working and what not working with the different approaches. And then finally, the work zone data exchange is a relatively new specification developed over the last couple of years, but it's not like there weren't data feeds coming out from a lot of different state and other agencies providing work zone related information as part of broader traveler information systems. A lot of states had those. So one of the things that I wanted to look at that's covered in an appendix is what's the relationship for how these new compliant feeds relates to these older traveler information data feeds, as well as I'd mentioned the Haas Alert Safety Cloud and what that does. And then there's a third initiative, the Road for Work Zones initiative that a company called Icones Products is leading the effort on, where their idea is to get with multiple vendors, not just their own company's products, but all different companies that make smart work zone devices, get together into a cooperative system where they get the data directly from the work zone devices, clean it up, organize it, and then provide that as a subscription service, both to state and local governments, as well as to these third-party agencies. And the idea is to, one, try to jumpstart getting out work zone data, because it could be a long time before all 50 states have work zone data compliant feeds of their own. And they're trying to be comprehensive and cover the country. Wherever any equipment from any of the cooperating manufacturers is found, they would have the data. So that would be to jumpstart that. And in addition, if you're a user, say you're Waze or you're an automaker, if there's 50 separate feeds, one for each state, you're going to have to set up an agreement to access the feed from each of the 50 states and use it. Their idea is they provide a one-stop shop to get data for the country. So the appendix looks at how these are all related and interrelated and compares them with one another as well. And of course, there'll be a webinar coming up later that goes into this particular work zone case study product in much more detail. And thank you. Next.
Great, thank you, Mike. Excuse me. I turn it over to Vaishali to talk about the two crowdsource products. Vaishali.
Thank you, Kelly. Happy to do so. So a little bit of background, and then I'll just quickly go over the two crowdsourced products. The Federal Highway Administration Everyday Counts program offered crowdsourcing for advancing operations as an innovation from 2018 through 2022. And during these two rounds of the program, our innovation worked with about 40 states and their local agencies to adopt and advance the use of crowdsourced data through webinars, workshops, peer exchanges, cohorts, or communities of practice. And much of the interactions and information exchanged in some of these venues were not published. And so this NCHRP project offered an opportunity to aggregate some of these interactions, these concerns, lessons into two primers, one which is this Ways for Cities partnership data, and a second one on vehicle probe data. The Ways for Cities program, if you're not familiar with it, is a free two-way data exchange that has the potential to help public sector operations and planning decision makers, the latter planning if the organization chooses to archive the data that's generated from Ways in real time. It was launched in 2014 with a few city partners, and since then, the program's probably expanded to nearly 2,000 partners all over the world, including city and state, as well as county government agencies, some academic institutions, and other partners. And today, probably about 40 plus state DOTs are Ways for Cities partners. Yet, not every partner necessarily understands or leverages the full potential of this free data. And not every partner or agency interested in joining the program understands the staffing and the data management resources needed to fully leverage this free data. And so, next slide. That's why we developed this primer. We wanted to provide a practical understanding of how state and local transportation agencies can access and use the data from the Ways for Cities partnership. Each of these documents, this Ways primer as well as the next one, is about 10 pages in length. It's pretty succinct, and it includes a list of references that agencies can use for more detailed information. The target audience is probably anyone that is interested in improving transportation operations from a TISMO perspective, as well as in terms of planning and safety analyses, and potentially conducting research. So broad audience, and the value proposition, again, it draws from some of the crowdsourcing innovations and offers a single source to get started. Next slide. And so what does the primer have? Starts with a introduction on what is Waze, talks about the sources of data that Waze uses. One is the active data from users of the Waze when they're driving around the roads, pushing a button saying crash ahead. And the app also passively collects information from the GPS information as well, as well as using that data to assess speed or travel time. So it describes the data. It shows a various set of data validation efforts done by Tennessee Department of Transportation, Virginia Department of Transportation, and others. It goes into some of the considerations in becoming a partner. What are you committing to giving in terms of data, and what will you receive from Waze from that partnership? And it delves into the strategies and tools to derive the greatest value from the data, and also spotlights some of the concerns. There is continued concern that Waze enables commercial vehicles to use the navigation app and end up on local roads. So there are a lot of concerns related to the use of Waze. That is a different issue than when agencies are accessing this data and sharing the data to help travelers make better informed decisions. So with that, let me move on to the second product in the crowdsourcing set, which is the Vehicle Probe Data Primer. And this primer is very similar to the Waze primer in that it sets up the context of why vehicle probe data and who we would want or who would want to access this data and how to access this data. So next slide. The primer, again, like the Waze one, talks about where data comes from. The fact is that vehicle probe data is no longer just vehicle probe data. Most vehicle probe data providers will go beyond commercial and private vehicle fleets and their GPS data. They integrate a number of other data sources, including data from Waze, potentially, data from connected cars, data from other third-party data providers. And they integrate and aggregate this data and provide a data feed that offers speed and travel times on roadways at what they call traffic message channel, TMC, road segments. It is an incredibly valuable resource for actively managing the road network, as well as for a number of operational planning and long-term planning purposes. One of the vehicle probe data providers offers the NPM RDS, the National Performance, I'm not going to get the acronym quite right, but it's an archive of data at 5-minute intervals on major roadway segments. And then there are real-time data providers that provide this information at a minute-by-minute and highly detailed road segments, a tenth of a mile even. So next slide. So this primer talks about the availability of probe data, increasing in availability not only for major highways, but even secondary roads and potentially even local roads. Talks about how agencies use this data, how they manage this data. This data, as well as the Waze data, can become big data, talking about terabytes of data annually. We talk about the Eastern Transportation Coalition and Iowa State University as two different entities that assess the quality of probe vehicle data, the first doing it on an annual basis. And we talk about how this data can be integrated with other data sources to provide better traveler information, traffic incident management, work zone management, and many of the other TISMO capabilities that agencies focus on. And we provide examples of that with Indiana, Colorado, Tennessee, and District DOT. And we talk about where the future of vehicle probe data lies and provide a list of resources for additional information. So with that, I will turn it back over to Kelly to cover the next product.
Thanks, Vaishali. So this product is titled Guide to Improving the Sharing, Quality, and Management of Data to Support Traffic Incident Management Use Cases. Next slide. So if this is a guide, I think it's a little less than 20 pages long, maybe about 15 pages long. The purpose of it is to provide lessons learned and recommendations for transportation agencies on improving sharing, quality, and management of TIM use cases. The target audience is local, regional, and state TIM programs, TIM coalitions or committees, operations staff, but could also extend to TIM partners. When we talk about, TIM use cases, is really a lot of a broad range of TIM use cases covering performance, planning and resource management, mobility and safety impacts of incidents and TIM activities, traveler information, advanced technology and data for TIM, and TIM policies and practices. But in order to be able to really implement some of these use cases, a lot of data is needed. Next slide. So, that upper right-hand diagram, what type of data on incidents would be ideal? Well, we'd ideally like to know when and where incidents occur, what type of incidents it is, whether it's a crash or a non-crash event, the circumstances surrounding the incidents, the who, when, and what of response, who comes, when they come, what they do, how long they're on the scene, the impacts of the incident in terms of number of lanes blocked, congestion, injuries, whether there's a secondary crash or a responder struck, and then the duration of the impacts, the roadway clearance time, the incident clearance time, and the time to normal flow. So there are a lot of sources of data on traffic incidents. I think more commonly, there's very few, like ATMS data, crash data are probably the primary sources. Maybe safety service patrol data are the most common sources of data for looking at probably most likely just the duration of the impacts, like roadway clearance time and incident clearance time. But there's so much more we could learn about traffic incident management if we had access to more data. And so the bottom right sort of shows, that transportation agencies have some data, but some of that data is also with other state agencies like state traffic records, or with partner agencies, EMS, fire, CAD, AVL, that comes from those partner agencies, or towing data, as well as third-party data. Vaishali talked about, mobile navigation app data can identify the location of incidents and the type of incidents. Probe data can help us understand how those incidents impact the network, and weather and connected vehicle data. So this product has 4 major sections. One is on TIM data sharing. It talks about some of the barriers, recommendations, and benefits associated with sharing data internally within DOTs, as well as externally with partner agencies and private data providers. That sort of helps expand that set of use cases for TIM. The second section focuses on data quality. There have been some previous recent studies that have really dived into data quality assessments of some of these data sets and identified some of the issues and limitations, and makes recommendations for how to start to improve some of the data quality. Next slide. The third section focuses on data management and some of the common data management challenges. There was a recent study, NCHRP 03138. It finished up earlier this year. And the research report just got published. It's research report 1071. And it focuses on how to use big data in support of TIM use cases, as well as some recommendations for better managing data, and particularly in a more modern way. So these are some of the recommendations that came out of that report, which you can find on TRB's website. And then the last section explores opportunities for agencies and TIM programs to accelerate the collection, sharing, and use of data to improve TIM practices and policies, performance, and the overall impacts of TIM traffic incidents on the transportation network. And that bottom center diagram shows some of those opportunities, like leveraging existing data. There's a lot of data out there that isn't used currently to analyze TIM and improve TIM. Data quality and standards is another opportunity for improvement. Working collaboratively with partner agencies is a huge opportunity to improve that data sharing. And I think the glue that kind of holds all three of these together is the modern data management approach, and taking a more modern approach to data management will help agencies leverage existing data, will facilitate a collaborative approach, as well as an improvement in data quality and standards. So that's it for that one. Next slide. So turning it back over to Mike. Mike's going to talk about two separate shared mobility data products. Mike?
Thanks, Kelly. Yeah, in the shared mobility data area, there were, as Kelly mentioned, two separate products that were developed. The first of them being a resource guide. Next slide. So what is the resource guide? Basically, there are tons of data of information sources out there that touch on shared mobility data, different aspects of it, good material, not so good material. Some of it is very narrow, some of it is very broad. So the idea was to develop a reference guide to help people who are looking for information decide what are the most useful places for them to look. So it basically serves as a curated guide to then lead you on to where might you want to look to get additional, more detailed information about whatever specific questions that you had, whether that was planning for implementing shared mobility systems and managing the data, managing an ongoing system, or how to utilize it in other areas such as transportation planning. So the target audience is public sector agencies. Here it would include a lot of localities, cities, counties, towns, as more so than state DOTs, because usually it's the former that are responsible for managing shared mobility services. And it covers all aspects of what you might use that data for, where it might be a shared mobility office that's responsible for managing the services, or transportation planners that want to use the data to look at broader planning issues, such as where might bike lanes be installed on city streets, or how do we integrate shared scooter systems to provide last mile services with transit operations. So I mentioned some of the value here is basically helping serve as a pointer to how to quickly get you to the answers you're looking to get from the broad array of information that's out there and available. And it covers both management of data, whether it's being done internally within an agency, or a lot of different agencies contract out for managing some of the data. And it's useful for them, though, as well, as what are the issues you need to be aware of if you're going to contract out this data? What are the things you need to put in your contracts for that? And what do you need to look out for? And the security guide provides basically one-page overviews of each of the resources that are included, and it includes over 40 different resources. And each one of those resources is cross-indexed both by the topics that are addressed by that resource and also by the type. Is it an article on the web? Is it a detailed research report? Is it a sample data set that's available out there? Is it an example feed of what's available to the public? So that covers a lot of different resource types as well. Next slide. So as I mentioned, each slide covers the what's out there in terms of the content. It looks at sample documents as well. It has some, it points you to sample agreements and includes some sample agreements that might be made with shared mobility operators regarding data, what data they need to provide, how they need to protect the data. It covers relevant data standards for mobility data, such as those coming out from the Open Mobility Foundation and open source software that helps manage or process that data. It talks about different organizations that organizers might want to be aware of, as well as providing example of public data sets and dashboards to look at. So each of those are the types of things that are included in the types of references in the guide. And that sort of covers quickly what's in the resource guide. Next slide. So the second product is a guidebook to help advise on how you should manage sensitive shared mobility data. Next slide. And by sensitive data here, it includes both data that may affect individuals' privacy, and there's a lot of information in the literature about that, but there's not as much about proprietary data and protecting proprietary data. And the scope of this guidebook is both data. If it's proprietary data that needs to be protected, it's sensitive. If it's data that may reveal private information about individuals, that's sensitive data that needs to be protected. And the scope is both. And the target audience, again, is public sector agency personnel, including those responsible for the mobility programs, but they need to work with their IT departments, their legal staff, and others that are they need to work with in order to protect privacy, to be aware of what rules and regulations and laws need to be followed along the way. And the goal here is that once you've read the guide, you're not going to be an expert on privacy protection or information security, but you're going to be able to hopefully talk intelligently with those experts, for example, in your IT department or in your legal department about the subjects and the things you need to care about. Next slide. And the way the guidebook is organized is after an introduction, it lays out a general process. What are the steps you should take and in what order in thinking about data and managing this shared mobility data, and then provides what are recommended best practices for each step along the way. The first major step is to determine the data needs. You know, in the early days of big data, a lot of advice was, oh, just grab everything. You never know when it might be useful. Well, there's an argument to be made there, but not if you're trying to protect people's privacy or protect proprietary data. Grabbing every piece of available information, storing it indefinitely, and having to protect it is probably not the best way. You probably actually do want to determine, why do I need this data? What am I going to use it for? What are the use cases? And then for each of those use cases, what data elements do I need? What information is needed so I can do my job to meet that use case? And then of that set of data that I need, what parts of that data are sensitive? Not all of it is, some of it is. What data is sensitive and needs to be protected? Then develop overall principles and policies for your organization to manage sensitive data. And this may be a subset of broader policies that your agency has in general for protecting private and proprietary data. And then it goes into appropriate controls and mechanisms for protecting the data that you have determined that is sensitive, whether that be access controls, data retention policies, what's the role of encryption, and other areas, some of the emerging technologies like something called differential privacy. And again, there'll be a separate webinar coming up later on this month that covers these two shared mobility products in much more detail. And with that, I'll turn it over for the next product.
Thanks, Mike. Ed, over to you.
Yeah. Okay. This is a discussion of software that was developed to serve a very specific purpose based on the needs that were identified by the NCHRP panel. Underlying all the data that's been talked about today are maps, and those maps have a lot of different characteristics depending on the sources and so forth. And so this was an effort to try and address specifically how to conflate and cross-index the maps associated with traffic message channel data and the from NRICS and the maps that the federal government requires of states on the Arno platform. Next slide, please. This turned into a software product, and basically what it was something that became browser based, utilizing JavaScript and then the MS Edge browser as a viewing platform. The use of the browser is really a convenience in terms of local operations. So the reason it was done this way was basically to provide some kind of user interface platform. There are related tools that were developed along the way. One was an implementation and deployment guide, and there is a slide which goes further in terms of that. And then an ongoing frequently asked questions, which is basically an effort to respond to questions that come up when the product is implemented in production. Like I said, it's a cross-indexing tool for taking care of network maps. Things were approached in a different way than this problem's been approached in the past, trying to connect the TMC to the Arnold data. And it was done using open source tools and open source data to make it easy for state DOTs to implement and also for local customization. It's along the way, one of the questions that still needs to be answered is how in the longer run it will be updated and also how it will be distributed. In terms of target audience, it's primarily the state DOTs, but anybody who is using the TMC big data sets of sensor data from roadside sensing can effectively use it. Next slide, please. So what is the new approach that we're talking about? Basically, in the past, most conflating efforts have been based strictly upon matching geography. And Linker AT does this. However, it adds to that by implementing what's called a route-based methodology. So the diagram off to the right there shows essentially how Linker AT figures out how it's going to connect the Arnold segments, which represent the same road segments, as the segments that are in the TMC database. So the beginning of the process is that it finds a point based on a combination of proximity of the two links and also the angle of the links in terms of their departure angles. It takes that information along with the information about identifying that link semantically and tries to find an end link using now the combination of looking for a specific identifier and geography. Then that process is reapplied to trace the links that connect the start link and the end link. So by using segment names, and efforts have been made to do this before, but most of the efforts in terms of looking at naming has been trying to reference one data set to another. Since what we're doing is we're actually connecting segments from the same data set, we don't have that problem. We're looking at basically using the information in the Arnold database to identify links which have similar route naming characteristics. There are advantages to this. The advantages, one is that because this can be broken out as a route by route problem, it can be updated and errors can be fixed at the level of the route, not at the level of the entire data set. And there's an extensive amount of information that comes out when you run the program, telling you about what kind of errors it's found and what potentially you can do about those. Next slide. So this is the interface associated with Linker AT. Basically, this provides you with a basic set of parameters and utilizes a data organizing model that all the data sets are structured into a directory structure that makes it relatively easy to determine for any one of these what you're using. It is locally computer based. It's not web based. It's not cloud based. It runs locally on your machine. It uses the standard web browser for its interface. And like I said, there's the route finding algorithm indexes and localizes the root corrections. So this helps in terms of getting through the process of dealing with errors that come up. It's based on open software and open data standards. The open software utilizes a package called TURF, which is the engine for doing geographic comparisons and so forth and so on. It sits on the JSON data platform, which is an open data standard for geographic information. Next slide. As I mentioned, there's a deployment guide and documentation. This is an attempt to kind of bring everything together in terms of both the methodology that we use with Linker AT and also how to access, install, and run Linker AT. It provides information, and it's still a little bit in development, although most of it's complete. But it provides information about the types of error codes that Linker AT will generate, the types of error reporting that Linker AT will do, and also has a certain amount of information about the statistics in terms of how well it is doing on finding a solution for a particular problem. Now, there is a portion of Linker AT where, because we do utilize the information which is specific to the states on the Arnold side, and that information varies from state to state, customization is required for each individual state. Right now, that customization has been done for Arkansas and for Colorado. And there is some guidelines in terms of how you can interpret the information that is in Arnold, so it can be done for other states. Next slide, please. And I am done, so I'll pass it on to you, Kelly, and you can introduce Brian.
Okay, thanks, Ed. Okay, Brian.
Hey folks, how are you? This is a product that we developed that was kind of born out of the fact that there was a lot of work that was done on the pilot efforts of the Integrated Corridor Management Program, USDOT sponsored pilot initiatives back in 2006. And the data systems back then have changed. The data systems now have changed a lot since those initial deployments. So the panel felt that there were new discoveries to be had with more recent deployments. Next slide. So this product, it's not a very long primer, so it's an easy read. It's less than 20 pages, and it will provide an update on some key management principles that were discovered through recent reviews of other literature since 2019, and then also interviews with two agencies that I'll talk about a little more in detail. The target audience is anyone that's really a transportation system practitioner, folks that might be in the IT world that are working with their transportation folks in the development of system architectures that support integrated corridor management systems. Next slide. So the three documents that were reviewed since, in addition to the discoveries that we came across under phase one, were these additional documents here. And then we also had interviews with folks at PennDOT on their new I-76 integrated corridor management system, and then it's also the I-24 smart corridor system that Tennessee DOT is doing, both very recent and ongoing developments that we were able to get fresh insights to on our recommendations, which can bring us to the final slide here. So a few of the summaries of these 5 key recommendations. Some might seem obvious, but they have been identified as some potential challenges, and these led to these recommendations. So as far as legacy equipment challenges, that, you know, if those are not fully considered in the planning and systems development phases, and really evaluated, that could result in higher costs. By way of example, Tennessee DOT had some challenges along their corridor where they had traffic signal controllers that were outdated and couldn't be integrated. So a full comprehensive system had some snags that weren't necessarily anticipated at the earlier planning stages. So again, the recommendation is to follow the tried and true practice of a systems engineering approach and work through those the identification of those legacy equipment challenges in the earlier stages of development. Decision support systems. There was a lot. That's probably one of the biggest changes that we saw since the earlier deployments from the pilot deployments of nearly 15 years ago. And our recommendation is that the decision support systems really need to be looked at on a case-by-case basis. And in one particular instance, there was evidence that a DSS was utilized for the first few months of an ICM, but then the operators found that there was not enough variability to really require the system to be deployed. So DSS really should be limited to those more complex and corridors that have probably more unanticipated incidents or events that where a decision support system could be useful. A corridor data policy. This was a real hindrance to some deployments, and then in particular in the earlier deployments too. So this tends to be an ongoing challenge where agencies, by the time they get to a data exchange architecture, have maybe misunderstood the data policies that another agency, participating agency, might be adhering to. And so while ideally you would discover these through the ConOps process, even in the earlier design stages, it is absolutely necessary to develop these corridor data policies. And a follow-on to this study would be that we would recommend the development of some templates that agencies could use in the development of things like memorandums of understanding. The TMD standards, these were always used, and they were done at a high level, but they're an essential starting point. But these, there should be iterated through the design process, and these standards should be reconsidered and reviewed to make sure that there's some consistency in how those are being deployed. In some of the mentions in the interviews were that it really is just a starting point, and that a lot of customization needed to be done. And then finally, a real essential area too was to create and identify early on either a central physical or virtual data hub a central physical data hub could be an option as well. And there was some evidence of agencies thinking that one agency would be the central facility rather than creating maybe a separate physical or cloud solution that could be shared instead of putting the ownership of that data source to one agency. So those were the key recommendations, and I pass it on to the next person.
Hey, thanks, Brian. All right, Ryan, bringing up the rear here. Your floor is yours.
Thanks, Kelly. So this product worked out to be more of a guidance document on looking at the use of connected vehicle data for transportation system management. And the connected vehicle data is specifically considered referred to data coming from physical infrastructure. It's RSUs and OBUs, roadside units and onboard units in the 5.9 gigahertz spectrum. Next slide, please. So the product type, again, is a guide. Really, the objective here is to look at the use cases where connected vehicle data can really be used to supplement traditional traffic data within traffic operations and really support proactive traffic management decisions. The target audience is really any agency or person utilizing TISMO practices. And what we're looking at is to bridge the gap between different departments within an agency at varying levels of background. So the document was kept mainly broad without going into details or sacrificing the idea of any specific type of system architecture where data flows through. And we stuck closely with the guidance from USDOT and the USDOT JPO office and the ARCIT infrastructure itself. Next slide, please. In the practical context, there's a lot of things that we considered for this, and we wanted to keep this as grounded as possible. And the ideas here is, that technology moves fast. There's a lot of different architectures and systems that exist within the connected vehicle infrastructure and ITS in general. There's a lot of different standard operating procedures and organizational capacities. And really what we intended to do was develop a guidance that was to inform the methodologies of applying and utilizing connected vehicle data for transportation management. The thing to keep in mind is that as technology changes, so do the data streams, so do the formats and protocols and interfaces. We tried to keep these methodologies as agnostic as possible to kind of counteract those changes and make sure that what we're talking about is something that can be used in viability for a long time, and focusing more on the practice of applying connected vehicle data to specific use cases. It's really not intended to inform direct detail within a specific organization or infrastructure or any sort of existing working methodology of how to apply the direct data inputs in there, other than discussing, what should the data inputs you would use for certain use cases based off the ARCIT infrastructure. Next slide, please. With connected vehicle data, there was a lot of things that we touched on inside of this document, inside the various sections. And it's kind of important to kind of discuss these pieces here, because we're dealing with data set that's ambiguous to most users, but also can be varying greatly depending on the amount of participants inside of a connected vehicle system. There was data that we did not specifically analyze or discuss how each system handles the data in varying formats and methods of processes, only because we wanted to keep this agnostic, but focus on the generalities of connected vehicle data that comes from the standardizations that exist. The thing to keep in mind too is that there's a lot of agencies that don't have first rights of access to their own data. So ensuring that you're using the highest quality information you possibly can with connected vehicle data systems is incredibly important. The data size itself can vary so greatly depending on the number of active participants and users, or even just elements within your system, as well as the amount of data that you can actually collect through your system. And the management of data also varies greatly. You have some systems that rely on cloud systems, you have centralized storage systems. So again, remaining agnostic to this is how we produced a guidance document that was more focused on the idea of how do you do something without contributing to the development of a specific system itself. And the important thing to keep in mind there is that, while connected vehicle data has a standard, it's mostly structured within the same format. It's not always provided or stored the same way. So there's different data handling procedures, storage system requirements within each system itself. And we discussed this inside of the document itself and the guidance. as a way to kind of focus on, these are the points that we did not touch on. We tried to remain, again, agnostic. Next slide, please. So the document itself is broken into really 3 major sections, focusing on first the introduction, going through connected vehicle itself, and more specifically the protocols and applications that we're going to be discussing here. The transportation system management CV data section focuses on the idea of what is data fusion and how are we considering data fusion within this, and what are we going to be suggesting for data fusion, and then discussing on the strategies between both vehicular-based connected vehicle applications and pedestrian cyclist connected vehicle applications. Next slide. The meat of the document is really broken into this transportation system management with connected vehicle data section, where let's repeat it. But in the vehicular strategy section, we focus in on the different use cases that would exist with connected vehicle and the various applications that have been deployed around the nation through the various projects led by state agencies or USDOT, and looked at how the data flows through the ARKit infrastructure and the service packages that exist through the standardization process with USDOT. This did the same thing for pedestrian, and really tried to gather the most information we could and produce, here's the applicable points to augment and supply additional data into the system where needed. I believe that's it. If you go to the next slide.
Thanks, Ryan.
Yep.
Okay. So I know that this was a lot of information. Again, it was a pretty long project, and there was a lot of outputs, and I appreciate you all sticking with us. Just a quick slide, a couple slides on next steps. So next slide. As we mentioned at the beginning, there are 4 subsequent webinars for this project. They're listed here. We've got one on shared mobility data, so we'll dive a little bit deeper into the 2 shared mobility products. That's on 2 weeks from today, same time. And then 2 weeks from that, we'll dive into the work zone case studies. And I do want to mention that it isn't just about our products, that we will have guest speakers that represent, state and nonprofit organizations and their sort of work with shared mobility data and work zone data as well. So you'll get to hear a little bit more about the particular product from this project, but also some of what others are doing and their experiences and recommendations. And then in December, we have 2 more. Ed will talk in more detail about the Linker AT, and particularly kind of what was done with Colorado, who was kind of our test case. And then the freight data management webinar will go a little bit into more detail into the freight products, as well as have some guest speakers on the use of freight data. And then upper right hand corner here is where you can register, same place you registered for this webinar. Looking forward to seeing you all at one or more of these future webinars. Next slide. And as far as the project, as I mentioned, this project ends at the end of the year. The products have all been reviewed by the panel. The comprehensive final report, which compiles all the products, has been submitted to TRB. And so we have these webinars, and any final reviews and the editorial review and publication processes that that TRB goes through will definitely carry into next year, but hopefully you will be able to access these the final research report sometime next year with all of the products. And next slide. So again, thank you for participating. We have a few minutes for questions and answers. If you have any other questions, feel free to contact me. That's my phone number and email. I'm happy to address any questions. And with that,
hi, Kelly. We have a couple of questions in the Q&A section.
okay. can you specify in detail a little bit how to use connected vehicle applications in pedestrian and bicycle? How does it work? From Huang Li. So Ryan?
Yeah, that's okay. So in the guidance, we looked at this from the perspective of the pedestrians being connected pedestrians, specifically outlined within the guidance too, that, you know, the way that it works is that it's, you know, its requirements that you gotta have some sort of either an emulated OBU or a physical OBU attached to pedestrians. And within that, we looked at the applications that extend it to PedSafe, the Safe Cyclist applications, and I believe one other within the document that where the data flows would go through and supply back into a transportation management center and look for where pedestrians are approaching intersections, where we might have opportunities to go ahead and preempt phasing, and that's a very speculative approach, as well as looking at safety metrics too, where we have potentially pedestrians in violations and things like that.
Thanks, Ryan.
Yep.
Are there any other questions from anyone that we can answer? Let's see. Brian, I have a question while we wait to see if there's any questions from the participants. In the research, are agencies integrating at the data level for ICMs currently?
Absolutely. Yeah, they are. They all are integrating. I think some of the things that we uncovered were the granularity of the data is sometimes not adequate for the objectives needed. For example, we spoke with an agency in California where there was an interest in trying to provide ridership information to travelers and in real time, potentially on apps, smartphone apps, or on dynamic message signs. And we couldn't do that because the ridership data was only collected at the end of the day. And so there was no means of doing it. So while the transit agency did have ridership data, it wasn't at the granularity or near real time to a point that could be utilized to provide shared and real-time information. So the answer to your question is complex. It is being done, sometimes not necessarily to the desired outcomes.
Thanks. Okay, Mike, I have a question for you on the work zone. There were 5 case studies that we looked at, and a range of technologies that were used, and not necessarily like the vendors, but is there any particular technology or device for collecting work zone event data that is sort of stands out or is particularly effective based on the research?
Right. I don't know if it stands out or effective, but in terms of where to start, and the most basic and the most widely used is definitely smart arrow boards. And one of the issues that people found with trying to collect real-time data, is, to be quick, is that the idea is that there's a lot of agencies have planning systems for work zones, but it might say, well, over the next 2 months, we're planning to rework these 20 miles of interstate, but they're not working on all 20 miles at once, and they're not working on it continuously for 2 months. So what's the real-time data? And when they tried to have the vendors, the construction companies say, well, you need to tell us where you're working, exactly when and how and whatever. And a lot of times it doesn't happen. It's not a priority. So it's automating that. And the really nice thing about automating a smart arrow board is basically it has GPS in it. you put it right at the start of the work zone to tell people the lane is closed. And it's set up such that when you turn it on to turn on the arrow, it sends back, I'm at this exact location at this time, and I'm pointing to say the right lane is closed, or I'm pointing to say the left lane is closed, and it's reporting automatically. So as soon as they turn on the system to use it just as an arrow, as a dumb arrow, it's automatically including the smart functions. So that's probably the place to start. And the most basic is, where are their work zones being worked in real time? And smart arrow boards are probably the key piece there.
Okay, thank you. I know we're at time, but we do have one more a question here. I am wondering whether there is any new collaborative opportunity for future connected vehicle research projects and shared mobility projects for someone who is outside of USA, like Canada. If so, with whom who should we communicate with? I think the question is directed at connected vehicle research projects and shared mobility research projects, and any potential contacts for collaboration. Brian, you put 5GAA.
Yeah, that is the consortium that has been put together to put forward C2X solutions, and it's agnostic of it. It's not geographically specific, so it is a worldwide organization.
Okay. All right.
All right. So thank you everyone for attending today's webinar. I also want to thank our panelists. We had a great discussion here today. As I mentioned in the beginning, a recorded version of the webinar will be available on NOCO's website. And on behalf of National Operations Center of Excellence and our presenters, thank you for joining us today, and have a great rest of your day. Thank you.